Today we're going to look at a different method of measuring our angles, and we're going to look at a way that we can measure our angles using real numbers and not degrees. Degrees are not real numbers, and so it's not possible to multiply or divide by degrees. So we have another method of measuring our angles. And in doing that, if we have an angle that cuts an arc equal to the length of the radius. So here we have our radius of r, and if the arc that's cut is measure r, then we say that we have a central angle of 1 radian. In this case, theta would equal 1 radian. So we're measuring our angles by the arc that's cut. And that measure of radians is where the radius and that arc that is cut are the same. And we'll have our measure of 1 radian. Let's look at a definition just a little bit different. If a central angle theta in a circle, so let's have a circle. If we have our circle here, and in a central angle, the central angle theta in a circle of a given radius r cuts off an arc length s. So we have our central angle theta, our radius is r, and our arc length is s. Then theta is equal to the arc length divided by the radius. And that will then tell us how many radians. And this is measuring theta in radians. So if we have our circle and our radius is 3 and our arc length is 6, then our central angle would be 6 divided by 3, or 2 radians. And that would be the measure then of our central angle, and it's based upon real numbers. If we had a radius of 6 and our arc length was 3 centimeters, we'll go ahead and give these units. Then our central angle would be 3 divided by 6, or 1/2 radians. If we had a radius of 1/4 centimeters and an arc length of 1/8 centimeter, then our central angle is going to be 1/8 divided by 1/4, and as you can see, the centimeters cancel, which we know is the same as 1/8 times the reciprocal, so times 4, which would give us 1/2 radians. And so we're going to measure our angle based upon the radius and the arc that's cut. Now, if we took a circle, and let's just say that the radius is r, and our arc length is the circumference. And we know that a formula for the circumference of a circle is 2 pi r. Then in this case, our central angle would be 2 pi r divided by r, which is 2 pi. So the central angle of a circle is 2 pi radians. or 1 full rotation then would be 2 pi radians. Now, let's look at some comparisons of our degrees and radians, because a lot of times you're given problems in degrees, but if you're going to do computations, then you have to change those to radians. So we know that 1 rotation is 360 degrees, and we just found that 1 rotation is also 2 pi radians. Well, if we want to see a comparison, let's divide both sides by 360 degrees and find out what 1 degree is equal to. So we get that 1 degree is equal to, well, our 2 and 360 would cancel or reduce, is equal to pi over 180 radians. So 1 degree is equal to pi over 180 radians. If we went back the other way, 360 degrees is equal to 2 pi radians. And we wanted 1 radian, so let's divide both sides by 2 pi. Then we're going to get 180 degrees over pi. 2 goes into 360 is equal to 1 radian. So now we have a way of converting or changing from degrees to radians and radians to degrees. We have a factor that we can multiply it by so that we can change. So let's say that we have 15 degrees and we want to change it to radians. Now, an easy way to remember this is using the dimensional analysis that you learn in chemistry and physics, in that we're wanting to get rid of degrees. And degrees are in our numerator now, so to get rid of the degrees, then what we're going to have to do is to go back and divide it by the degree part. So we're going to multiply 15 degrees by pi over 180. And that's going to cancel our degrees. And 15 will go into 180 12 times. So 15 degrees is equal to pi over 12 radians. Let's do another one. Let's say we want to change 210 degrees. Then we're going to multiply it by pi over 180. And let's see, 30 will go into both of these. 30 goes into 210 7 times, and 30 goes into 186 times. So we end up with 7 pi over 6 radians. So to change from degrees to radians, you're going to multiply your degrees by pi over 180. If we want to change radians to degrees, let's say we have 3 pi over 4 radians, and we want to change that to degrees. Well, then we're going to multiply by 180 over pi. It's the pi's we're wanting to get rid of. And even if we didn't have pi here, if it were just a real number, we would still multiply it by 180 over pi. But our pi's cancel. And 4 is going to go into 180 45 times. So 3 times 45 is 135 degrees. If we have 5 pi over 6, and we want to change this, then we're going to multiply it by 180 over pi. Our pi's will cancel. 6 is going to go into 180 30 times, and 5 times 30 is 150. So we can change from degrees to radians by multiplying by pi over 180, or change from radians to degrees by multiplying by 180 over pi. Okay, let's just look at some comparisons here and drawing some of our radians, our drawings and our angles in both radians and degrees, and look at some similarities. So what we're going to do first of all is we're going to uh, draw an angle in standard position. We're going to convert that angle to radians, and then we're going to figure out what our reference angle is in degrees and radians. So let's start off with 60 degrees. Okay, we want to draw our angle in standard position. So from the positive x-axis, we would have our 60 degrees. Now, let's see what 60 degrees is in radians. And remember, 60 degrees is one of our special angles. So eventually you're going to want to know what that is in radians without having to go through and convert it. But we'll multiply 60 by pi over 180. And 60 goes into 180 3 times, so it's pi over 3. So our reference angle is pi over 3. Remember, your reference angle is between the terminal side and the x-axis. Now let's try 120 degrees. We're going to draw this in standard position. So going from our x-axis, we will rotate around, and we'll be in the second quadrant. And that's a 120 degrees. Okay, let's see what this is in radians. So we'll do 120 by pi over 180. Now 60 will go into 122 times. 60 goes into 180 3 times. So we get 2 pi over 3. So 120 degrees is the same as 2 pi over 3 radians. Now let's see what our reference angle is. And remember, your reference angle is between the terminal side and the x-axis. So we know if we went all the way to the x-axis, that would be 180 degrees. 120 is outside our angle. So in degrees, that would be 180 minus 120 would be 60 degrees. We have a reference angle of 60 degrees. Okay, let's look at that in radians. Now, if we go all the way around a circle, that's 2 pi radians. So if we're going halfway, that would be pi radians. So if we're just going to our axis over here, it would be pi. Well, our angle is 2/3, so we're going to have 1 pi minus 2/3 pi, or 2 pi over 3. Now 1 pi would be 3/3 minus 2 pi over 3 would end up being pi over 3. And that should make sense that if our reference angle in degrees is 60, then our reference angle in radians would be pi over 3, because we learned right up here that 60 degrees is pi over 3. Okay, let's look at 300 degrees. We draw our angle in standard position. Now 300 degrees times pi over 180. Well, 60 goes into 305 times. 60 goes into 180 3 times. So this is 5 pi over 3. So 300 degrees is the same as 5 pi over 3 radians. Okay, our reference angle all the way around was 360 degrees. 300 of that's outside our angle, our reference angle. So our reference angle was 360, minus 300, which was 60 degrees. So what do you think our reference angle is in radians? It's going to be pi over 3. Now let's just see how we would get that. All the way around was 2 pi radians. And 5 pi over 3 is outside our reference angle. So 2, we need a common denominator. So 2 is 6/3, 2 times 3, minus 5 pi over 3 is pi over 3. Now, one of the things you should have noticed here is every time in radians our denominator's 3, our reference angle ends up being pi over 3. So it makes it a little bit easier. You're going to know immediately when your denominator's 3 that your reference angle is pi over 3 or 60. So we need to keep that in mind. Then all you have to do is to figure out which quadrant you're in. And we'll look at that in a little bit so that you can get an easier idea of knowing which quadrant that you're going to be in. Okay, now let's do the same thing, except let's do it where our angle is given to us in radians, and we're going to draw the angle in standard position. We're going to change it to degree measure, and we're going to figure out what the reference angle is in both radians and degrees. Now, eventually what you want to be able to do is to work with radians just as easily as you work with angles. And you want to think in radians. You don't want to have to constantly change, use that converter to change from radians back to degrees to know what you're working with. You want to know when you see your radian what you're dealing with. So let's take pi over 6. And we want to draw this. Now, here's where you've got to stop and think. And so we would look at how to know which quadrant you were in. We know that we start off at 0, and we talked that halfway would be pi, and then all the way back is 2 pi radians. Okay, so one of the things that I always look at is when I'm drawing it is my angle, is this less than 1 so that I'm either in quadrant 1 or 2, or is it greater than 1 where the numerator is bigger than the denominator so that I'm in quadrant 3 or 4? Well, 1/6 is less than 1. So then I have to decide, well, am I closer to 0? Am I closer to 1? Well, we know that 3/6 is half, so yes, I'm closer to 0. And I always like to think of it as just closer to 0 or closer to 1 because that's usually pretty easy to figure out. So this means that we're in quadrant 1. So we have our measure of pi over 6 radians. And we've drawn it in standard position. Now let's change this to degrees. So we're going to multiply this by 180 over pi. Our pi's cancel. 6 goes into 180 30 times. So pi over 6 is 30 degrees. Now since we're in quadrant 1, then those are our reference angles. Okay, let's take one of 4, let's do 5 pi over 6. Okay, we want to draw this. Now we have to think, first of all, how does it compare? Is 5/6 less than 1 or greater than 1? Well, 5/6 is less than 1. Your numerator is smaller than your denominator. So that means we're either in quadrant 1 or quadrant 2. So is 5/6 closer to 0 or is it closer to 1? And here you might want to think of 1 as 6/6 so that you can kind of compare. So is it closer to 0/6 or 6/6? Well, 5/6 is almost 6/6. So we're over here in quadrant 2. So 5 pi over 6. Now, before we even change this to degrees, let's go ahead and get our reference angle. I just said that this was 1, and I said you might want to think of it as 6/6. Radians are pretty easy to work with because you're going to be dealing with whole numbers. So 1 is 6/6, 2 would be 12/6. So our reference angle is going to be 6/6 minus the 5/6. So we just figured up that our reference angle is pi over 6. 6/6 minus 5/6 is pi over 6. Okay, let's see what our angle would be in degrees. So 5 pi over 6 times 180 over pi. Our pi's cancel. 6 goes into 180 30 times. 5 times 30 is 150. So our angle in degrees would be 150. Our reference angle then would be 180 minus 150, or 30 degrees. And just like we saw a while ago, every time our denominator was 3, our reference angle was 60. Our reference angle was pi over 3, which was 60. Every time our denominator is 6, our reference angle is going to be 30, or pi over 6. So when you see a denominator of 6, then you're going to know that your reference angle is pi over 6, which is 30 degrees. So if we had 11 pi over 6, we want to draw it in standard position. Now, 11/6 is greater than 1. So we're past 6/6, but we're not to 12/6. This is 2 pi, so it would be 12/6. But 11/6 is closer to 12 than it is to 6, so that means we're over here in the fourth quadrant. So that's our angle of 11 pi over 6. And our reference angle, it's easy to see, would be 1/6. 12/6 minus 11/6 is 1/6. And we just said, anytime your denominator is 6, your reference angle is pi over 6. So we already know that that's going to be 30 degrees will be our reference angle there. And you're not going to be changing these to degrees every time. You're going to learn to just work with this in radians. Right now we're doing that so that you get a little bit more familiar with the radians and degrees. And so our reference angle is 30 degrees. And so we know then our angle would be 360 minus 30. Our angle would be 330 degrees. And you could use the conversion, multiply that by 180 over pi, and you would get 330 degrees. So now we already know anytime in radians that our denominator is 6, our reference angle is 30. When our denominator was 3, our reference angle was 60. Let's just go ahead and look at 3 pi over 4. Okay, 3/4, that's less than 1. So is it closer to 0/4 or 4/4? Well, 3/4 is closer to 4/4. So we're in our second quadrant. So our reference angle would be 4/4 minus 3/4. Our reference angle is pi over 4. So 3 pi over 4 times 180 over pi. The pi's cancel. 4 goes into 180 45 times. 3 times 45 is 135. So 3 pi over 4 is the same as 135 degrees. Well, to get our reference angle for 135, we would say 180 minus 135, which is 45 degrees. And we're not going to go through all of these, but anytime your denominator is 4, your reference angle is pi over 4, and it's going to be 45 degrees. So those were our special angles. 30, which is pi over 6, 45, which is pi over 4, 60, which is pi over 3. And you should know those very clearly and easily. Now, we just looked at our quadrants. 0 was pi. 0 was 0, excuse me. 180 was pi. So 90 is halfway between 0 and 1, so 90 would be pi over 2. And 270 is halfway between 1 and 2, so it would be 3 pi over 2. So anytime your denominator's 2, you're on the y-axis. When your denominator is 1, you're on the x-axis. So it's fairly easy to know when you have one of your special angles. Now, let's just look at one or two more of these. That's not a special angle. 7 pi over 12. We want to draw this in standard position. Well, 7/12 is less than 1. So 0 would be 0/12. 1 pi would be 12/12. So is 7/12 closer to 0 or 12? Well, 7's closer to 12. We know that halfway would be 6. So we're in our second quadrant. That would be our 7 pi over 12. If we wanted to know our reference angle, well, then it's simply 12/12 minus 7/12, which is 5 pi over 12. And you could change those degrees if you wanted to, but I want you to learn to work with your radians just as easily as you work with degrees. So let's say that we have 5 pi over let's make it 15 pi over 7 over 11. 15 pi over 11. And that kind of looks like a pi there. So let me erase that. 15 pi over 11. Okay, we want to draw this in standard position. Well, 15 elevenths, 15 is greater than 11, so that's greater than 1. So 1 would be 11 elevenths pi. 2 would be 22 elevenths pi. So we need to decide, is 15 closer to 11 or 22? So here we are now in the third quadrant, and we want to know our reference angle. Well, 15, we've gone all the way, we've gone past, we're at 15 elevenths. We know that 11 elevenths was outside of our angle, so that would give us a reference angle of 4 elevenths pi. So you should be able to work with your degrees and your radians. And you don't want to constantly have to convert. Some of them, your special angles, you want to be able to do immediately. Okay, let's look at our calculator and how you would go about changing from degrees to radians on the calculator if you needed to. And we won't do this an awful lot. We will work with the formula that we looked at already. But let's say that we want to change 120 degrees, 40 minutes to radians. And that one would be hard to do using our formula. So what we do is, first of all, we need to put our calculator in the radian mode. Whatever you're wanting to change it to is the mode that you want to have it in. So let's put our calculator in the radian mode. Okay, then what we do is we're going to put parentheses. We'll put 120 degrees, 40 minutes, we will close our parentheses, and then we're going to do second apps number 1. And that changes that then to radians. So it's kind of, you're in the radian mode, you have to tell it that you have degrees. And since we had degrees and minutes, then we had to put all of that in and then tell it that we had degrees. Now, another way that we could do this is just to use our formula. So we could put in 120 degrees, 40 minutes, and then we could multiply that by pi, divided by 180. And you can see that it gave us the same answer. So it's a process. To actually change it on the calculator doesn't always make a lot of sense, and so you can still change it by multiplying it by your formula. Uh, so if we wanted to change 56 degrees, we can have 56 Okay, we'll put 56 degrees, and then we just press enter, and it changes it. We had to do the parentheses on the last problem because it had degrees and minutes. Okay, if we wanted to change from radians to degrees, okay, what we do is we put our calculator then in the degree mode. That's what we're wanting our answer to end up with. And we're going to enter the radians, so we would put parentheses. Let's say we've got 4 pi divided by 3. Now, if you remember a while ago when we did 4 pi divided by 3, when our denominator was 3, our reference angle was 60. And 4/3, that's bigger than 1, so that means we're in the third quadrant. So reference angle of 60 in the third quadrant would be 180 plus 60, 240. And we'll do this several different ways. But now we want to change this. So what we do is we go to second angle. And notice number 3 is an R. So we're saying that this is in radians. We want it in degrees. And it didn't give it to us in degrees. Did I get my mode right? Thought I entered it and changed it to degrees. I guess I didn't do a good job. So let's go back and we'll do our parentheses 4 pi divided by 3. Then we need to tell it that that's radians. And we get 240. You can see it's actually easier just to use the formula. And again, we could have done 4 pi divided by 3, then times 180 divided by pi. And it turns up just, I put 181, not 180. So let me go back and change that. And we get 240 degrees. So you can use your calculator, but I think over the years I found that it's a little bit easier just to use the formula and your brain. Okay, let's look at how we would go about finding some functions then of our angles. And we're going to look mainly at ones that we should actually know. And anytime your reference angle is 30, 60, 45, we've already said you give exact answers. So that means anytime if it's in radians that your denominator's 3, 4, 6, 1 or 2, you're going to give exact answers. So we're going to look at finding our functions for a few of our angles. Let's say that we want the cosine of 4 pi over 3. Okay, what I do first of all is I think what my reference angle is. My reference angle is pi over 3, which you can, since we already memorized them in degrees, pi over 3, that was 60. So we have a reference angle of 60. Now, the cosine of 60 is 1/2. So our answer is going to be 1/2, but then we have to figure up the quadrant that we're in so we know if it's positive 1/2 or negative 1/2. And we learned earlier which ones are positive and which quadrant. Okay, figuring up our quadrant. 4 is bigger than 3, so we're past 1. So we're past 3/3, but we're not to 6/3. This is 1 pi, this is 2 pi. So we're either in the third or the fourth quadrant. Well, 4 is closer to 3 than it is to 6, so we're in the third quadrant. In the third quadrant, cosine is negative. Let's say that we want the tangent of 7 pi over 6. Okay, let's think first of all our reference angle. Our reference angle is pi over 6. When it's over 6, it's 30 degrees. So our reference angle is 30. The tangent of 30 we memorized earlier was the square root of 3 over 3. Now we have to decide which quadrant we're in. Well, 7, 6, 7's greater than 6. So we're either in the third or the fourth. 1 would be 6/6, 2 would be 12/6. And 7 is closer to 6, so we're in the third quadrant. In the third quadrant, tangent's positive. If we wanted the cosine of 7 pi over 4. Okay, we said when our denominator was 4, our reference angle was 45. It's pi over 4, which is 45. We've memorized that the cosine of 45 is the square root of 2 over 2. Then we need to figure up the quadrant. Every time you're doing a function of an angle, you need to think reference angle, quadrant. Okay, 7/4. 7's greater than 4, so we're either in the third or the fourth. Well, 1 pi would be 4/4. 2 pi is 8/4. 7 is closer to 8, so we're in the fourth quadrant. In the fourth quadrant, cosine is positive. Okay, if we had let's do the secant of 5 pi over 6. We'll do a reciprocal function. Okay, our reference angle is pi over 6, or 30. Now the secant is the reciprocal of cosine. The cosine of 30 is the square root of 3 over 2. So the secant would be 2 over the square root of 3. And let's go ahead and rationalize that. So that would be 2 square roots of 3 over 3. Now we need to decide the quadrant. 5/6, that's less than 1. And 5/6 is closer to 6/6 than 0/6. So we're in the second quadrant. In the second quadrant, cosine is negative. So it would be negative 2 square roots of 3 over 3. You think reference angle, then you think quadrant, just so that you can get whether it's positive or negative. And let's look at one more. Let's say we want the cosecant of 3 pi over 2. Okay, we said when our denominator was 2, we were on the y-axis. This was pi over 2, and 270 was 3 pi over 2. So we're at 270. The cosecant's the reciprocal of sine. What we memorized was up here at 90. The sine of 90 was 1. So the sine of 270 would be negative 1. And 1 and negative 1 are its own reciprocal. So this would simply be negative 1. Okay. And let's look at an angle where we've got a negative angle. Let's say we want 2 times the cosine of negative pi over 6. Okay, pi over 6, our reference angle is 6, which is 30 degrees. Cosine of 30 is square root of 3 over 2. Now, all that the negative does for the angle, remember, is we rotate then clockwise. So we would be here in the fourth quadrant. We've just rotated negative pi over 6. In the fourth quadrant, cosine's positive. So the cosine of negative pi over 6 would be square root of 3 over 2. And then we're going to multiply that by 2, which would end up being the square root of 3. So we can come up with some exact values. And any time that your reference angle is going to be a 30, 60, 45, or a quadrant, we need exact values. So let's look at where we evaluate some things. Let's find the sine of, and this is just a practice, of 2x, and we're going to be told that x is pi over 6. So we want the sine of 2 times pi over 6. Now, we've got to do this multiplication first. We're finding the sine of this value, so that would be the sine of pi over 3. Okay, reference angle 60, the sine of 60 is square root of 3 over 2. And we're in the first quadrant, so it's positive. And these are not anything special, it's just giving us a little bit of practice. if we want 4 cosine of 2 times x plus pi over 3, and again, we're going to let x be pi over 6. Then we've got 4 cosine 2 times pi over 6 plus pi over 3. Order of operations say we do what's in the parentheses first. So that would be pi over 3 plus pi over 3, or 2 pi over 3. Now we have to evaluate our function first. So this is going to be 4 times. Reference angle is 60. Since the denominator is 3, our reference angle is 60. Cosine of 60 is 1/2. We need to know the quadrant. 2/3. That's less than 1, so we're either in the first or the second quadrant. This would be 1 pi, which would be 3/3. And 2/3 is closer to 3/3 than it is to 0, so we're in the second quadrant. In the second quadrant, cosine is negative. Then 4 times negative 1/2 would be negative 2. So we're just using some computations to help us get down to working with radians. Let's look at one more thing. And again, this is just to help us work with our radians. Let's say that we're told that y equals sine x. And we want to evaluate this when x is equal to 0, pi over 4, pi over 2, 3 pi over 4, and pi. We just picked these values. So we want to find out what this is equal to. So y equals the sine of 0, which we know is 0. These are going to be ones that we know. Y equals the sine of pi over 4. Well, the reference angle, when the denominator's 4, reference angle's 45. The sine of 45, square root of 2 over 2. Y equals the sine of pi over 2. When the denominator's 2, remember we're on the y-axis. That's 90. The sine of 90 is 1. Y equals the sine of 3 pi over 4. Okay, our reference angle is pi over 4, which is 45. We know that the sine of 45 is square root of 2 over 2. 3/4 is in the second quadrant. In the second quadrant, sine is positive. And then y equals the sine of pi, which is the same as 180, and that would be 0. So we can go through then and find our functions. And mainly what we're dealing with is trying to learn to work with radians as easily as we work with degrees. And so you need to know how to change from radians to degrees, degrees to radians. You need to be able to find the sine, cosine, and tangent, and your reciprocal functions for your special angles as they're in radians. And you don't want to have to do the computation to change them to radians. You want to be able to recognize when the denominator's 3, your reference angle is 60. Denominator is 6, your reference angle is 30. Denominator's 4, your reference angle is 45. And we know what those are, and then be able to know which quadrant you're in.